Area and solids. We're going to talk about prisms and cylinders. Prisms and cylinders. Please make note of the location that you are watching this video, as well as the date and time that you are watching it. Turn off any distractions. That includes your smartphone. Let's take a look at what we have here. Let's review from our previous lesson. In our previous lesson, we studied something called nets. I'd like you to take the solid below and unfold it into a flat net. Then, I actually want you to find the area of the net. So, area is your ultimate question. I'd like you to do this on your own. So stop the video, attempt to finish this problem, and then restart the video and check your work. Okay, let's see how you did. First, we want to unfold this. So I have a top and a bottom, and I trace it, and I see that I have a pentagon. Connected with 1, 2, 3, 4, 5 rectangles. 1, 2, 3, 4, 5, and then we have another pentagon. So I have 2 pentagons and 5 rectangles. The pentagons are the same, so I'm going to find the area of one pentagon. Then I'll simply times it by 2, and then I'm going to find the area of one rectangle and times it by 5. The area of the pentagon, remember, area of any regular polygon is perimeter times apothem over 2. That's the area. So I find my perimeter. I walk it around for perimeter. That's 1, 2, 3, 4, 5. My edge length there is 10. So area equals perimeter times apothem over 2. Do physical pickup. Perimeter is 10 times 5, which is 50, times apothem. Physically trace the apothem, pick it up, times 6.9. It's going to be over 2. And then we're going to times by 2, because we have 2 of them. So in this case, that actually cancels the 2 there. So we simply need to do 50 times 6.9. And we get 345. Check for units. We don't have any units, so I'm just going to say units squared. Now our rectangle, one edge length of our rectangle is the same as 10 here. And then our height is 7. So area of a rectangle is length times width. My length is 10. My width is 7. That's 70 times 5. 5 times 7 is 35. That is 0. So I have 350 units squared. To find the total area of the, if this were a box unfolded, this would be considered the total. We call this surface area. It's going to be 345 plus 350. That's 5, 9, 6. 695, and we aren't given units, so we're just going to call it units squared. We box it and label it. That is the area of the total net. This is a precursor of actually something that we're doing today. Again, we're going to be talking about solids. This is your basic solid family. So we have 2 primary families when we're dealing with solids, 2 of them. We have what's called the prism and cylinder family. And then we have the pyramid and cone family. Let's draw these, and then you try to figure out How are these related? Remember, family is based on how people are related to each other. Mother, father, child, okay, aunts, uncles, everybody's related. So in these family of solids, they are related in a certain way. They have a common characteristics. So first, we're going to start by drawing a square-based rectangular prism. This is something you're probably familiar with when you doodle. So start drawing with me. Notice the dotted edges. The dotted edges imply depth. That, because the base technically is a square, but we just call it a rectangle because technically squares are rectangles, we'll call this a rectangular prism. Let's take this. We're going to pull this down into a prism. I'm going to redraw the base here and just connect it. This is a triangular prism, named because of the bases are triangles. This one we're going to pull down into a prism. And this, because you can see that our bases are pentagons, we call this a pentagonal prism. And then in the same family here, we actually have a cylinder, which is very easy to draw. You just draw a squashed circle. Draw another squashed circle. Technically, that's an ellipse. Dot the back to show depth, and of course you have a cylinder. All of these shapes are related in some fashion. That is a family, a prism and cylinder family. Let's take a look here at the pyramid and cone family. Pyramid and cones all come to what's called a vertex. A singular vertex. So we're going to draw in the corners to that vertex. And this is a square-based pyramid. Corner to vertex. This would be a triangular pyramid. This one, connect corner to vertex. And of course, that's a pentagon, so we'll call this a pentagonal pyramid. And of course, is your cone coming to a vertex. Sweep the front, dot the back to show depth, and that would be a cone. So pause the video just for a second and ask yourself, what makes prisms and cylinders in common? What makes them a family? And what makes pyramids and cones a family? Really stop and get that stuck in your head. It should only take you about 20 seconds to formulate a thought. But I'd really like you to think about it. What makes those solids related to each other? Okay, welcome back. You should have noticed something along these lines. In all prisms and cylinders, there are two bases. Prisms and cylinders, you have two bases. And they're connected by rectangles. Basically, a cylinder is one giant rectangle. In a pyramid, you only have one base. And we're connected by triangles this time, except for the cone, which is its own shape. So for this lesson, we're going to stay focused on the prism and cylinder family. Before we talk about prisms and cylinders, we need to differentiate between these two words, the concept of a right cylinder or a right prism, and an oblique cylinder and an oblique prism. Why is it important to distinguish this? Because all the equations we're going to learn in the next 10 minutes only apply to right cylinders and right prisms. They do not apply to oblique. You're going to be covering oblique prisms and cylinders when you hit calculus. So let's do a quick definition. I want you to watch carefully and be ready to define and differentiate between a right prism and an oblique prism. This is a right cylinder. It also could be a right prism. Notice that the height and the base is at a right angle. If I drag this over sideways, notice if I were to drop down, the side of the pyramid the side of the cylinder is no longer at a right angle here. That makes it oblique. Oblique means sideways or at a diagonal. So when the height and the base are at exactly a right angle, that's called a right prism or a right cylinder. If this edge here along the side does not form a right angle with the base, that's called oblique. That means it's at an angle. And in this case, the equations that we're learning today do not work. So we're only going to be working with a right cylinder and a right prism. Okay, so in a right cylinder, the height is at a right angle to the base. The height is at a right angle to the base. That's why it's called a right cylinder. In an oblique setting, you're going to be sideways at an angle. Think of the Leaning Tower of Pisa here. This is not a right angle. So I'd like you, in your own words, to write a sentence. What is the difference between a right prism and an oblique prism? Take the time to write your own sentence and differentiate that in your brain. Now the next is a very, very critical skill. In a prism and a cylinder, you have two bases, always two bases. Those two bases have these properties. They are congruent, they are parallel shapes, and then they're connected by rectangles. The two bases are congruent and parallel shapes connected by rectangles. I beg you, always be in the habit of shading and tracing the two bases right off the bat, immediately, as soon as you see a prism. Shade the two bases and trace the two bases, the edge of them. In a cylinder, the circular bases are connected by a singular long rectangle. But technically, it's still a rectangle. So it says in the prisms below, identify the bases by shading and tracing. I'm going to do the first two, and then I'd like you to pause the video and do the rest on your own and then check to see if you're accurate. Again, what are we looking for? We're looking for two congruent, parallel shapes connected by rectangles. Let's take a look at this first one. Well, here we see rectangles and we see triangles. We have 3 rectangles and 2 triangles. The bases are the 2 congruent shapes. So that would force the triangles to be the bases here. So we shade and trace. Very important you do both. Shade and trace the bases. Then if you look carefully, you can see those 2 bases are connected by 3 rectangles. So in this case, our bases are here. Now watch very carefully at the one on the right. Again, we see triangles and rectangles. Where's the base? We see 3 rectangles here, 3 rectangles, and then we see 2 triangles here in this shape. The bases, again, there's only 2 of them, and they're congruent and they're parallel. So our bases are these 2 triangles. Base does not mean bottom. So these are the bases here, connected by what's called the faces, which are the rectangles. So these are the bases. And then the rectangles that connect them are called a face. I'd like you to pause the video and attempt to identify, shade and trace the 2 bases in the rest of the prisms and cylinders. Go. Okay, let's see how you did. In this one, these 2 would be your bases. In this one, this would be your base, and that would be a base. Again, base does not mean bottom. 2 congruent shapes, parallel, connected by rectangles. Here, this would be your base, and this one. Trace and shade. This one's a little tricky, but if you look closely, we see rectangles and trapezoids here, but there's only 2 trapezoids and 4 rectangles. So the trapezoids are going to be the bases here. Those are your bases. Again, base does not mean bottom. Base is 2 congruent parallel shapes connected by rectangles. Our bases here are the circles. Now, these rectangles get a little bit tricky here. Our bases are 2 congruent parallel, exclusively congruent, would be these 2 would be our bases, connected by congruent rectangles. I know the top and bottom there are congruent and parallel, but you technically have 4 congruent rectangles connected by 2 squares there, so that would be considered your bases. Identifying the bases and working with prisms and cylinders is a very critical skill. Now, there's another piece of vocabulary we need to talk about, and that is the difference between what's called lateral area and surface area. Now imagine you have a soup can here. You've all seen a soup can like this. And the soup can, you have the actual aluminum, and then you have the paper around the edge. I'd like you to draw a diagram that would show the soup can label removed from the soup can, and ask yourself, what would that look like? Pause and draw that. Well, you should be able to recognize if we were to slice the edge of the label here and unfold it, you'd end up with a long rectangle. That would be the soup label. And then you'd be left with an aluminum can without its label on. This actually represents the 2 different kinds of area. Label is the area around the can, just around the outside of the can, that would be called the label area. The technical name for that is lateral. It's the area around the lateral, which means the sides of the cylinder, lateral area. And then the surface area is the total aluminum can, the total aluminum can. So the lateral area would just be the label around the can. So imagine if we were to put this label back on and wrap it around, that would be what's called lateral area. But underneath the lateral area is the aluminum, and then here, imagine, surface area has to include this top and bottom base. So lateral area is actually included in the surface area. I'd like you to pause the video right now and write your own sentence explaining the difference between lateral area and surface area. It's very important that you understand the difference between those two terms. Write a sentence in your own words describing that difference. Basically, you can see that the surface area of a solid is its lateral area, in this case, plus 2 bases. 2 bases. It's the lateral area, it's the area under the label, plus the area of 2 bases. Now let's get down to actually the equations we're going to use with prisms and cylinders. For lateral area, to find the lateral area of a prism or a cylinder, it's simply 2 steps. The lateral area is going to be the length of the perimeter times height, and height is distance between the bases. Height does not mean up and down. Height is distance between bases. So in a cylinder, that perimeter here is actually circumference. So we use circumference times height. And the surface area would be whatever that lateral area is. So that total lateral area, so we're just going to write LA, plus the area of 2 bases. I'm going to use a capital B here because capital B means area of the base. Capital B means area of the base. In a prism, we start by finding the perimeter of the bases. So we trace and shade our bases. We shade the bases, and then we trace. So we find the perimeter of one base, perimeter, times the height. Height is distance between the bases. That would be considered the lateral area, and then the surface area is the lateral area again, plus the area of 2 bases. Capital B means area of. Now, how do you know which capital B to use? That is going to be determined by what the shape of the base is. Here, our bases are circles, so our B here is going to be pi r squared. Here, our bases are triangles, so that's going to be 1/2 lowercase base, because that's an edge, times the height of the triangle. So your capital B's all come from this chart, depending on what shape it is. You need to memorize that. Okay, let's walk through one problem together. Whenever you work with prisms, you're going to follow these steps. You're going to shade and trace, find the perimeter, find the base, write out your equations, and then do circle, plug, chug. Shade, trace, perimeter, base. Equations, circle, plug, chug. Shade, trace, perimeter, base. Equations, circle, plug, chug. Say it with me one time through. Shade, trace, perimeter, base. Equations, circle, plug, chug. Let's try this with one problem together. We're going to shade and trace the bases. Well, we see 3 rectangles and 2 triangles. Because there's 2 triangles, that must be your bases. So I'm going to shade them. And then I'm going to trace. Step 1, I want to find shade, trace. I want to find the perimeter of a base. So I walk it around here and I see I have 7 plus 24 plus, whoops, we don't know that. That's really easy, and if you know your triplets, it's even easier than that. This is a 7, 24, 25 right triangle. It's a triplet. If you have no idea where that 25 comes from, you must do it longhand, which would be like so. 7 squared plus 24 squared equals unknown squared. You solve here, you're going to end up with 625 equals x squared. You square root, you're going to end up with x equals 25. So our perimeter, notice I'm using a capital P, I add 7 plus 24, that's 31, plus 25, it's 56. So 56 is our perimeter. Next, I want to find the area of the base. Area, that's a right triangle, so area equals leg times leg over 2. So I'm going to go 7 times 24 over 2 is my area. 2 goes into 24 12 times, 7 times 12. 7 times 10 is 70. 7 times 2 is 14, so that's going to be 84. And do we have units? We don't know. We'll call it units squared. So our base area, notice I'm using a B here. That means base area is 84 units squared. This is 56 units. Now we write our 3 equations out for lateral area. Our lateral area is perimeter times the height. Surface area is lateral area plus 2 bases. Now we do circle, plug, chug. We circle perimeter. Well, we already found perimeter. 56. Height. Height is the distance between the bases. So in this case, it's 28. So 56 times 28, 1,568. And that's lateral area, so it's units squared. Now, surface area. Surface area is whatever the lateral area is, plus the area of 2 bases. Well, where do we get our bases from? We already found our bases up here. That's why you do that immediately. So we're going to come up here and we're going to do 84 times 2 plus 1,568. We get 1,736. And it's units squared. That's how you find lateral area and surface area of a prism. Let's try one more using a cylinder. We're going to find the lateral and surface area of the following cylinder. We're going to follow these steps: shade, trace, perimeter, base, equations, circle, plug, chug. Step 1, we want to shade our bases. Then we trace the edge here. That shade, trace. Now we're going to find the perimeter. In this case, perimeter technically is circumference. So perimeter, which is circumference, is d pi. And our diameter here, if our radius is 4, our diameter is 8. So we're simply going to say it's 8 pi, and we have no units, so we're just going to write units. That is our C. Now I want to find area of the base, and it's a circle, so it's pi r squared. So it's 4 times 4, which is 16, so we're going to say it's 16 pi units squared. This is going to be our circumference. This is the area of our base. Now we're going to write our equations. Our equations for lateral area of a cylinder is circumference times height. Surface area is lateral area plus 2 bases. Now we're going to do circle, plug, chug. Circumference, we already found it. It's 8 pi. Height, distance between the bases, 12. We do 8 times 12. 8 times 10 is 80. 8 times 2 is 16, so 80 plus 16, we end up with 96 pi. That's our lateral area. Now we're going to take this lateral area and plug it in right up here. So we have 96 pi plus the area of 2 bases. We already have the bases, 16 pi. So 2 times 16 is 32, so I have 96 pi plus 32 pi. 96 plus 32. My final answer here for the surface area is 128 pi, whatever my units are, squared. Now you can leave it in pi form, or if we want to multiply this out, we can do 96 times pi, and that's 301.6, whatever the units are, squared. And the other one is 128 times pi, that's 402.1 units squared. That's lateral area and surface area. Lateral area and surface area. Now I'd like you to actually take a 2 or 3 minute break because we have another 8 minutes left in this video and it's a little bit longer than your normal 25 minutes. So please hit the pause button, stand up and stretch, go get a cold glass of juice, and come on back. So before we move on, we need to distinguish between area and volume. Area and volume. So imagine here if you had a gift, a wrapped gift. In that wrapped gift, surface area would be like the wrapping paper. It's the outer part of the gift. It's the decoration. It's the outer part. It measures the outer area of a solid. Volume would be the amount of stuff, how big the box is on the inside. Inside. Now, to find the volume of a cylinder or prism, it's actually quite easy. It's much easier than working with surface area. So take a look here at this prism. In this prism, this is a triangular prism here. And you can see here as I move this around that that gray area would be the base. Now to deal with volume, see right here, look closely, if my gray area, let's get that to a nice even number so you can see it here. Well, whatever, you see that the area of the base, which is gray, it's 67.5 and 67.5. So if I bring this down with my height to 0, now I simply have the area of the base. And in this case, the triangle area is 67.5. So to find volume, you start by finding the area of the base. Then you simply times by the height. Notice, watch those numbers on the right-hand side. Those numbers get bigger. In other words, the volume increases as the height increases. So let me show that once again to you. If you look closely, the gray area is area of the base, 67.5 in this diagram. I could change it if I want. Okay, as I move this around. So now my area is closer to 100, my area of my base. And then I times by the height. And watch, as I increase the height, the volume also increases. So volume is simply area of the base times the height. Volume is area of the base, underline that word area, times the height. And remember, height means the distance between the bases. Very important. The distance between the bases is the height. So to find volume, it's area of the base. Notice I use a capital B to represent area of the base times the height. Let's apply this to our prism earlier. Step number 1, we're going to shade and trace the bases. Our bases, we have 2 triangles here and 3 rectangles, so that makes my triangles my bases. Now I'm going to find the area of one base, and if it's a right triangle, the area of the base is leg times leg over 2. So I'm going to go 7 times 24 over 2. We actually did this earlier here. That goes in there 12 times. So 7 times 10 is 70. So it's 84. So the area of my base, notice I'm using a capital B here, is 84 units squared. Volume is simply base times the height. So I'm going to do circle, plug, chug. I circle base, I physically pick up the base, it's 84. Height, very important. 7 is not the height here. The height is the distance between the bases. So it's 28. So I do 84 times 28. You get 2,352. In this case, whatever our units would be cubed, because now we're dealing in 3 dimensions. Let's take a shot at one problem together. For this one, we're going to find all 3 things. We're going to find the lateral area, the surface area, and the volume. We're going to follow these steps: shade, trace, perimeter, base, equations, circle, plug, chug. Step number 1. Let's shade and trace the bases. So my bases here, of course, are the 2 circles. So I've identified my base here. Now, shade, trace. I want to find my perimeter, which in this case, my perimeter is circumference. So I'm going to write my equation. Circumference equals d pi. And I see my diameter here. Physical pickup is 22, so it's simply 22 pi. And we do have units this time, so it's inches. That's my C. Now I want to find the area of my base, and that's apple pie is really, really good. Be careful here. Our radius is not 22, it's 11. So we do 11 squared times pi. 11 times 11 is a perfect square. That's going to be 121 pi inches squared. That is going to be our B. Remember, B is area of the base. Now we write our equations out. Lateral area is circumference times height. Surface area is lateral area plus 2 bases. Volume is base times height. Circle, plug, chug. Circumference, we already have it, is 22 pi. times our height, which is the distance between the bases, so it's 10. 22 times 10 gives our lateral area is 220 pi inches squared. Now we take that lateral area and we plug it in right there. And we already have our base, 121 pi. So I'm going to do 121 times 2. We get 242. So we end up with 220 pi plus 242 pi. Treat pi like x. Basically, you can ignore it for the moment. And we end up with 462 pi. That's our surface area. 462 pi inches squared. Now last one, volume. Volume, we already have our base again, 121 pi, times our height, which we already have, is 10. 121 times 10, just add a 0, so our volume is going to be 1,210 pi inches cubed. Watch your units here. Your units change because we're dealing with volume. So our answers are 220 pi inches squared for lateral area, 462 pi inches squared for surface area, 1,210 pi inches cubed for volume. You can multiply pi in if you so choose.